Hi, welcome to this third session on the March edition of the Open Security Summit. It's basically on the Glamorous Toolkit, which is one of the most exciting pieces of technology that I've found recently. And we have Tudor here, which is one of the key developers and the driver behind it. He does have a sore throat because this is the third one we're doing this week. And, you can see the other recordings that have happened, which I actually highly recommend. They're on the site. There's a part two. There's some really good stuff that went. So the part one was basically Tudor really going through how it works. Part two, we talk about the use cases. And I think on part three, I just want to drive with some of the comments I have, and Tudor is going to chip in. But we also have a couple of people here that have already been involved also using it. So again, we'll bring them in, and then we'll take it from there. So I guess that the first thing is where to get it. So you can, I just literally did this. So you can go to the website, you can download it, right? You can download from here. I just download the Mac version. Once you download it, then ask you to run. There's a little image that you need to pick, and then it kind of looks like this when it starts. So that's basically the UI that you have here. It is quite interesting. So basically it uses, I think already, its own development to show how it works, which is a great way to do it. So you can see, and this is kind of what Tudor went on the first session. The first, in a way I would say that the way this clicked for me was when Tudor was talking about this idea of we can represent a lot of the content that we have and the ideas and the information that we have in name value pairs. The problem is there's not a lot of context, right? There's not a lot of context into how this actually works, where you can see, here you have 6 things. What are they? Well, once you put them like this, you actually see that they have context. There's a particular view, and Tudor is very big into worldly maps. And again, one of the things that you also, when you think of this from a mapping point of view, there is not just one way of thinking about it. And the same thing, there's not just one way of representing each of these. The idea, and this is again what clicks to me, is this idea of creating a visual representation, creating an analysis, a tool. Actually, what do you call it? I think you have the worldly maps here, right? I'll go into your map. Here we go, right? So this is, there you go. There's the map that Feng, which is the company that is behind the Glamorous framework, which by the way is open source. Again, you can get it from there, and then you can see that what basically it's doing is taking that when you're looking at a particular problem or you want to do an assessment, instead of having a manual view, with the Glamorous framework, the Glamorous Toolkit, sorry, allows you to have these sort of generated custom views for the data that you have at hand, or in a way the specific problem. So the logic here is that instead of looking at something like this, right, i.e., which is basically very, the analysis is, if you think about it, this analysis here is very on the Genesis side, custom build, right? Like you can try to build something on top of it, or you can use a visualization or a tool, or in this case, a view that already renders, that as a division, renders this as a file system, renders that as an image, and renders that as an abstract syntax tree of the particular content, right? And then this be a graph representation of what was there. So I think this is where it gets very interesting. And when also if you see the presentations, Tudor talks about this moldable development, right? This idea that you mold the environment to what you need it to be in order to make you productive. So I think of this as feedback loops, right? I think of this as, I want to have a very effective feedback loop based on a particular set of inputs. I want to be able to not just consume the information, but I want to be able to manipulate it. I want to be able to modify it. I want to be able to keep almost thinking molding it, right? Tinkering with it, molding that view until it just becomes easy. And I have to say that in my development experience, I used to think of these, like it's almost like I gladly let myself go on tangents when I'm solving a problem, because I hit on something and say, well, it should be easy to visualize this. Like, it should be easy to see that output. And then I would go and build a toolkit. That's what I did with the O2 platform, what I did with the OWASP security bot. I would go out and build a toolkit or a visualization or a way to consume it, so that instead of dealing like this, I deal with the representation of it. And this toolkit is basically what allows this to happen in a very effective way. And you can see that even just, in a way to tell the story. Like, if you look at this, right, the way that, in this case, we're using the toolkit to allow to tell a particular story with interactivity, with live data, live information. This is amazing, right? Because it allows then the story of, or almost the message that you want to basically convey, even more importantly, adapted to the audience that you have. So you might have an audience that you just want to show something like this, but you might have other audiences that you want to go more into the technical details of what's happening because they care about that. So again, I really like this idea that, this sort of moldable environment, so this dynamic environment that is super powerful in how you do these things. And again, you can see things like this, where, again, you're telling a story, right? Which is important because, it all helps with communication, right? And from a technical point of view, I'm still getting my heads around this, but my understanding is that this is the view that you create. That's which one is the method? I think that's the view that you create. This represents that view, right? Which is this, and then that's, yes. Yeah. And then this becomes that kind of meta language that, almost like domain-specific language that they created here that allows a lot of this stuff to be created, right? But this is super powerful because if you look at this, right, it means that, is it real time? Can I change it?
No, it won't work here, but yes,
okay.
It should.
All right. All right, almost. But it's super powerful to be able to represent your idea into something like this, who then gets rendered in something like this for a customer, right? Or let's say for the end user. Like, one area that has, it seems that, and the guys are on the call, I would like, it'd be good if you guys can chip in, because, one of the things that I feel that, is already a good hit is this ability to use this toolkit to understand an environment, right? Understand language, or understand, I'm trying to find, this is live documents. There you go, right? I think that's the parser, right? Next. To understand that's the stack, sorry. Understand technology, understand architecture, which I maybe now you can just chip in a bit to this. Like, this is an area that, is interesting because you make this comment to say you love legacy software, right? You love projects that you basically be giving almost these things that people don't understand, because, I can see where you're coming from now, because that you are just a couple of views away. You are a couple of modules away to get understanding, right? So I used to have the same experience when I used to do security assessments, because, I almost said, I don't care what framework you have. I have my toolkit, right? It's called the O2 platform, but I have my toolkit that I'm going to arrive. I'm going to spend the first 2 days mapping your platform. Then I'm going to find, a truckload of vulnerabilities, because most of the times I'm already testing your app in ways that even you can't test it, or I already understand your app in ways that even you can't understand it. And that's usually where a lot of the security vulnerabilities tend to occur. So I really relate to that idea of, you don't care almost what's on the other side. You have your toolkit, right? Maybe for the ones who are old enough, the sports Billy bag, the Inspector Gadget bag, where, you just have all this ability to create, these tools. But the best part is that the more you do it, the better your toolkit becomes. So it's not like you spend a huge amount of time in a project and then that's it. There's no value added. When you can package into this sort of REPL, which is a read, execute, loop, and print, this is like REPL on steroids, right? Like REPL plus, right? But if you can capture like this, you then scale and you accelerate a lot, right? And I guess maybe my first question for you is, have you found that the more you use this, this concept or this approach, actually the bigger the software is, the faster you go, instead of being the bigger the software is, the slower you go?
What we definitely see is, first of all, just seeing you summarizing it and knowing that you didn't know much about it, just a couple, like a few hours of looking at it before, it's just amazing. Because one of the things that we get, and like people tell us, okay, is how difficult is this? Like, isn't this, because it's a foreign concept, right? It's this idea that you will be spending and development energy instead of just developing. Oh, now I have to build tools. Oh, but that's so expensive. But then like the economics are the other way around, right? So like if you don't build the tools, it's expensive. But if you build the tools, then it becomes much cheaper. So anyway, seeing you summarizing this after just a short exposure to what we've done, it's just amazing, because we see this too. Like usually when we go in a team, let's say the team has 10 people, usually 1 in 10 would click on it, like would just boom. It would click a little, but with you, it's a little bit. It's absolutely fascinating to actually see you summarizing too, because like people, there's one thing to click on it and then another one to explain it. So that's super cool. Now back to your question, what we do see is that the amount of waste that happens today in software is unimaginable. Mm-hmm. It's mind-boggling. Yep. We do see that software gets larger, way larger than it needs to be, for example, because people don't know what's inside. So the only other option is to build another black box on top of the other black box. Yep. Right? But if you can look inside of it, and if you can make the change exactly where you want to make the change, lots of things are open. That's on the one hand. But even if you have a system and it's already large, refactoring it or moving it from doing or adapting it for new business needs, that definitely should not be an impediment. And today it is an impediment. Like today, it is literally business threatening to have a legacy system that is at the core of your business, right? Because people simply cannot move. And we see companies like that all the time. And this is completely avoidable. There's no need for it to be like that. Every legacy system should be an opportunity. Will this mean that you go faster and faster? The more you know, the more of these tools you build, the faster you will get. Because you will be able to connect with people. Like, for example, just say, one of the use cases is, how do you get business? So not just like in the last session, we talked about architecture, for example. It's just one of those issues. Now, one problem there is, how do you raise architecture at a business level decision making? So how do you make the board, like the investment board, understand how and why they should invest in architecture as an investment, make an investment in architecture rather than treat architecture as a cost. So people always complain, like in development, that the business doesn't understand. Of course they don't understand, because we don't explain. Yep. But if you're able to explain, the conversation completely changes. So one of the ways we actually work with the C-level, like for example, a CIO, maybe a CTO, to help them make the business case about why software is an investment and not a cost, and then basically explain where we are, where do we want to go, how long, but not necessarily how long, but how long, how is it progressing, how do you communicate all of that? So this is on the technical side, but then the even more interesting things happen on the business side. So people talk about domain-driven domain-driven design and building this ubiquitous language that allow both the business and the technical people to communicate with one another and basically co-create. And that's all great as long as everybody sees the language. Usually that happens on a whiteboard, right? But a whiteboard is only meaningful if the system doesn't exist, right? Because a whiteboard will depict either of the two. It's a handmade picture is either represents a wish or a belief. So it's a wish if the system doesn't exist, and it's a belief if the system exists, because that's you think that it is. A wish is a great thing to aim for. So you want to use that one as a wish. You definitely don't want to use that one as as a belief. The system should be the system's responsibility. As soon as a human deems a representation important, it should be the system's responsibility to carry it forward. If you want, I can show you a case of how we use that and how we communicate not the architecture, for example, but the business domain, and help people communicate.
Can you show that today?
Yeah, I can show you now.
Cool. But actually, before you do that, let's just unpack a couple of things that you were saying, right? So just to clarify, the comment I made on speed, and I think it's something that you should think a little bit about, is that I now view a good software development. And again, I come this from a security angle, right? So, but also from an engineer, because I'm now a CTO and a CISO, right? So I can wear both hats. But I can already completely make the case to say that if an application or an environment cannot easily make changes, right? Where they can't make fixes or bugs or security fixes or even new simple things, right? That, sometimes you see these, feature requests and it's almost embarrassing, right? Because they are so trivial fundamentally, right? Compared to sometimes what the platform does. But the platform is now so overloaded, is so risky to make changes that even simple things take lots of time. So I view this as, and this is something I should do a PhD on this, right? So and I've experienced this. There is a slowness that occurs the more complexity the software hits. But it's not just complexity. So this is what's interesting. That's easy to understand. It's not just complexity, it's your ability to understand the side effects of what you are doing. So we get away a little bit with testing, and testing helps to sort of reduce that a little bit because testing allows you to make changes without, with confidence that you're not breaking too much stuff, right? The problem is testing, again, fell into a religion, and people almost forgot to almost ask why we're doing testing. And actually the fact that sometimes testing, and I would probably even say tooling, right? Because tooling is part of testing, right? Is sometimes needs to be as important as the main code base, right? I'm getting to the point where I'm almost saying the main code base should be super simple. There should be no black magic. It should be easy to analyze, easy to model. I don't want rock science, rock star coding in my production code. I don't want a bit of code that two people in the world can understand what the hell is going on in there, right? I want a bit of code that is simple, easy, refactored, and scales, right? But what it means that you only get there with lots and lots and lots of refactoring, and you only get there with lots and lots of really good tooling. So my point here is that when you develop like this, right? And I have been privileged to develop a couple of projects where we kind of were using this. We were not using, the Glamorous Toolkit, but the concept was exactly that. Keep building tools, keep building visualizations, keep building ways to allow us as developers and architects to really understand what's going on. And what I experienced was this acceleration, right? And then but it was itchy because it took me a while to understand why. And the reason why you should accelerate is because the same way that complexity kills you, but actually, if every time you build something, you build a toolkit, it's like Lego, right? Suddenly, when you want to do a new feature, it's easy because you already got this bit and you got that bit and you got that bit. So you almost like keep abstracting. And then the worldly maps gave me the visual representation is if every time you code, you are productizing your objects, you're productizing your views, you're productizing, how the building blocks of what you're building and how you visualize it and how you understand it. You're dealing more and more and more with these high level abstractions who are much more efficient ways to do something like that, which is actually what AWS is doing, right? The Amazon playbook is exactly that, right? It's commoditizing things and allowing us to mix and match. So I think a very interesting metric for this kind of development, your moldable toolkit development, it's what actually test-driven development should almost be called, right? Which is this environment where you're building more and more capabilities so that when you look at the business value that you provide, it's super high all the time because you have that speed. You have that speed of reacting to customers, to business opportunities, to users, to basically what your platform needs to do.
Yeah, so I agree, and it's interesting that you started at the beginning by saying that this is a feedback loop, right? You were talking about the feedback loop. So if you think about testing added a feedback loop where basically by replacing manual work, so clicks basically, with automation, and that introduced a new kind of feedback loop that was much fun, much tighter, and that generated a whole new kind of level of value. So our ability to construct functionality increased many times over, because we had that one. The thing about, like if you think just, we're talking here about security. Security is hard to capture as a unit test. Right? It's the wrong tool for that. So functionality is a way to check, to introduce feedback loops. But there are many other things. For example, architecture is orthogonal to functionality. And you can't, it's very hard, or it's very expensive, even if you can, to capture architecture through tests. But there are other ways to test for those, because in the end, a test is nothing but an analysis. Right? It just takes lots of data, dynamic data, that in that case, and then summarize it into red and green. But an architectural constraint is also exactly the same, except that it doesn't take functional data. It takes other kind of data, like structural data, and checks for that. And that's orthogonal to functionality. And that's the interesting thing, because again, like if the only thing, like if this, you were talking about the religion, if the only thing that you have is this, say, oh, this is the one tool, that's the one feedback loop, you're going to miss a whole lot of possibilities, because you're seeing three-dimensional rather than two-dimensional, and boom, you're just, things that are supposed to be simple all of a sudden are not because they are difficult, but because of the way that the problem is decomposed. So what you see with Glamorous Toolkit, and of course, in the same thing as with testing, like it's not like people have not done testing before TDD became a thing. But the thing was, it was not done or systematically for pretty much all functionality you want to think of, right? And that's basically where what we want Glamorous Toolkit to be. We want this to be the first vehicle where people can say, how would it be if you're building tools for pretty much every single development problem you have?
But then what you need, I want to add this here, right? What you need, right, is to put tests at all levels. So one of the things that was very frustrating to me when I really got into testing was I realized how primitive the tests are, right? Because of the way they run. So for example, one of the things, one of the most spectacular tests that I remember writing were tests that actually take into account an AST, actually took into account dynamic data, where in a way, so I always feel that we don't have a good definition of test, because my definition of test is something that tests something, right? Literally, it's a unit of X, whatever size is, and I have an hypothesis that I want to validate. So for example, like I want to write a unit test. Of course, it's not a unit test. Let's say, a test, right? On top of this diagram, right? Because this diagram is telling me a lot of things, right? And so, for example, I want to test, for example, that today passes when this is green and there's only one green there and there's a one, purple there, and that's what I want, right? So if suddenly one of these guys becomes purple, whatever that means, let's say that has an implication, I want my test to fail. Right? Because the problem is these are things that, for example, are very easy to write at this level. For example, I want all of these to be white, let's say, right? So I want a test that confirms that all of them are white, right? I want a test that confirms that at the moment, the only way to hit that center there is from here and from there. I don't want, let's say this is the attack surface. Let's say these outer edges are the outside world. So I don't want this and that guy to be exposed. I just want that endpoint or that endpoint. So I think, this, what I like about this is creating better and better, toolkits, right? Better and better abstraction layers, so we can test at all layers, so that when you make a change further down the food chain, you can see the side effects of that trickling up, right? Good and bad, right? Of how everything fits together, right? So I feel that the test paradigm is key. The problem is most tests, and because of the failure of developing toolkits for the tests, end up either being pushed to unit tests, which is easy to make them useless, either drive them to integration tests, which means they're crazy expensive because, again, they don't consume good metrics, and almost becomes this thing that never really fulfills its potential, because I feel that the things that we're testing on top of are still very primitive. They still code, right? And there's only so much you can do. Look, my party trick these days is everybody that has a Terraform script or a CloudFormation or an AWS environment or cloud environment, I ask, how do you test that? How do you test your CloudFormation script? And they're going, well, but it's supposed to be declarative. I'm like, so is coding, right? But how do you know that your CloudFormation script just didn't broke half the things? How do you know that the latest change that you put on that security group has not caused all sorts of side effects inside that container over there, right? But we I think what's powerful about this is this gives us the ability to be realistic, to talk about end-to-end visualizations that go from very, very high level all the way down to the code, right?
Yeah.
And I would say that one thing I would comment a little bit, you know, the way you explain, right, the diagram. And look, I'm the first one to say that if somebody has to grab a pen and draw on a board, it's already, you lost the battle already, right? But usually the problem is not there, right? The problem is not that somebody cannot draw it, because you can always draw it and create a digital version of it, right? You know, you could always do that. Depends, in fact, depends which side of the project you're in, right? The problem is that you don't have a feedback loop between making a change in the code tomorrow or architecture tomorrow and that diagram, but also more importantly, you know, being able to drill down to the levels of complexity that each layer has, always keeping sight of the big picture, but almost having this altitude problem, right? Also altitude capability where I want to, and this is the problem with this architecture, like I'm talking, with this type of design, in most cases, I've seen this with Profile, there's a bunch of end tools that have done this, but it never tends to be used in the real world because you can't, sometimes people struggle to connect this view with meaning, with actually what happens in the code itself. And that can only happen when it's an evolution at every single layer that eventually you arrive at that, you know, bigger picture, almost like you connect the dots, right? Between high level and low level.
Yeah. So, okay, this is very cool. Two things to complement what you're saying. So, indeed, the problem is not that people are drawing. The problem is what's the input that went into the drawing? Because the input, if the input is the outcome of manual inspection, then that by definition is not complete, simply because your system is much larger than one can inspect manually. You cannot do that. It's just too much information, which means that there will have been some summary, and you just don't know how far you are from the reality. That's the problem. And that's a variable you just don't want to have. I mean, building systems is already complicated enough. You do not want to not know what you have. That just should not be a variable. That's one. But the second one, and this is interesting, like, for example, if you think about how people are dealing with static analysis, for example, like people are using static analysis checks in their development environment, but just how do they do it? Most of the time, people are downloading some, the 1,000 rules, and then pick from the 1,000 rules the 50 or the 100 rules that make sense, or that they say, this is what applies to our code base, and then they run it. And then sometime later, you'll find that this system will have zero failing tests, and 1,000 or 10,000 warnings. What's the difference? Why? I mean, do they not care? Well, if they wouldn't care, they wouldn't have zero failing tests. It's not that they don't care, but the nature of the check is different. So nobody downloads a unit test from the web, for example. Everybody creates a unit test within the context of the system that they are building. Why? Because they encode value in the assertion. Mm-hmm. That value, it represents, it's highly contextual for that system, because software is highly contextual. Because software is highly contextual, we cannot predict specific problems people will have. We can only predict classes of problems that people will have. And as a consequence, if you download the rule from somewhere, and that rule is applicable for me and it's applicable for you, then by definition, it will capture what's common between us, which by definition would also not be able to capture what's contextual for me. So it's not going to be valuable. And that's the reason why people don't stop to fix it, because there's no value there, or there's very limited value there. So it's not the technology that is the most important, because the technology is really the same. It's just some check, right? Some analysis, which is automatic. But how what you put in it. And that you were hinting at to what level of abstraction, but you can also think of it also as what level of how contextual is it for you, right? So how does it capture your specific value? And that's basically it. And you can apply that principle to absolutely every single tool you have, right? And you were saying, it's so easy to get now tools that give you shiny pictures and everything is, colorful and so cool and shades of beautiful things. And then you look at, and then you asked one question. So when was the last time you made an important or a relevant decision based on the outcome of that tool? And if the answer was not yesterday or so, you probably want to throw it away. And I've seen tools that costed hundreds of thousands in licenses or whatever that had no impact over any decision for years.
Man, 50% of the security spend falls into that category, man.
So this is the other way around, right? So that's where the change is, right? And you start from the context and then you build the tool, not the other way around. That's why you want a language with which to be able to construct these tools very quickly, and that's what basically Glamorous Toolkit is.
Yes, but there's one thing that you I think you mentioned several times, which I actually would say you have to be a little bit careful, which is this idea that you're almost implying that teams are okay with not knowing, right? Almost they don't know because they don't want to, or they haven't invested a little bit, right? I think, and I know you don't mean that. I'm just saying that you can come out, because the way it can come out that way, and the way I think where you add value, right, and where Glamorous Toolkits add value is in this concept of it's now possible to understand what's going on, right? Like if you think about it, like I can take, given a bit of budget, I can take any system and I can get it to the point where we understand it better, right? I can get it to the point where even when you say, it's a guess, fair enough. Like you could spend X amount of pounds for X amount of period and X amount of resources, and you can get a decent, let's say, certain level of picture, right? The problem is actually the thing you mentioned just now, which is you do that, but how many good decisions you're going to make because of that? Like, what's the return of investment of doing that? And at the moment, I would argue that until the practice that you have here, this moldable development that you have, until you take that into account, is simply not practical. Like it's a mix of people, process, and technology, but technology is important, right? This is a piece of technology that allows a certain type of behavior to be possible. And this is a kind of technology that allows a scalable behavior to be possible. So I would argue that there's a lot of people that would love to have this, and a lot of people who spend lots of money trying to achieve similar goals, they tend to fail, or at least not to achieve the desired goals, because they didn't almost start by this principle that what we're doing is building toolkits, right? And we're building toolkits to make it better a little bit today, a little bit. It's the 1% improvement. Our job is to build a mini tool that gives me 1% improvement. Great. Tomorrow, you have the compound effect of that 1%. So now I'm going to build another tool that gives me another percent and another percent. And then by the time you have 20, 30, 40, 50% improvement, not because you want to do the 50% in the big bang, but you had this evolution to get there.
No, you're completely right. So and in fact, we're even saying that, at the end, our goal with Glamorous Toolkit is to start the conversation. Our problem is that people don't talk about how they read code, right? We spend all this amount of time, and it generates so much frustration, both for the developers and for business or for whoever consumes the software, that we think it's completely, like, we're in a place which is completely not sustainable. Our goal is to make and what we're saying is that with Glamorous Toolkit, we just want people to say, exactly like you were saying, now it's possible. And so if you think about, go back 10 years into DevOps, right? The kinds of things that are possible today were unpredictable 10 years ago for most people, because this was not a subject of conversation. Like, there are whole new business models that are possible today that were not really imaginable 10 years ago. And the difference between now and then is that we made this a subject of conversation. And what we're saying here is, and that's our goal, main goal is to make this a subject of conversation. Glamorous Toolkit is a technology, the first technology that makes this the systematic case. But I'm sure that there will be, people copying this one. But the key element is exactly what you're saying. That is, it's not people. I'm sure we know that people crave for something like this. We just need to help them decompose the problem such that their energy is going to be spent in the right way. And at the end of the day, we should start measuring how many times do developers smile when they work with legacy systems per day. Because today, people never associate working with legacy as something that can be beautiful, and we think it can. And so that's ultimately what we care for, and definitely.
Yeah. By the way, man, like most teams that work today, their code is already a legacy, right? Like my joke with AWS is that if a company that is using AWS, for example, or Azure, but AWS is just out of the park, doesn't stop for a week or two after the AWS main conference in November, right? They are already legacy, right? Because AWS is now on a path where they shift to the right. They productize so heavily that what you actually see is this very interesting archaeology, right, of a company that picked what AWS could do or Azure could do 2 years ago or a year ago, and then they go on this path, and then it's already legacy, right? So look, I would argue that any system that doesn't have this is legacy. Because the people that are coding it tomorrow have no idea how the freaking thing works. Because the people that build it today didn't build a toolkit and didn't make it easy to change, easy to modify. So these days, yes, you get some benefits from using cloud technologies or using mature development environments, but you're still making the same mess, right? I see the same mess in the cloud environment that you see on a mainframe application, right? That you see on a Java freaking spaghetti code. But guess what? I showed you, your current cloud architecture, and it's the same spaghetti, right? You maybe don't see it all, but once you try to unpick everything, it's the same freaking confusion, right? It's the same puppies, right? And there's, some companies that are better than others, of course. But I feel it is that ability to understand what you do that is key, right? And one of the interesting comments I wanted to make to you is that and I had the same problem because I'm all into graphs. So if you talk to anybody who knows me, they'll say, Dennis doesn't bring a graph, in a conversation, right? He hasn't spoke for enough, right? But I love graphs because it's something that I had an epiphany, right? Because everything clicked on it. But what I realized is that not everybody thinks in graphs. So one of my favorite moments, I did this analysis. So we had a static analysis tool, and I created a view like this, for example, right? And I remember showing that to a lot of the sales guys and a lot of the company internally. And there was half the room said, I don't get it. That looks complex. What you should like this, this thing here is insanely complex, right? And there was this guy that I love, this guy called Bruce, right? He turns around and say, that is simplicity at its maximum. It takes me 10 hours to generate what these guys just generated, right, in 5 minutes or 10 minutes. And he can now analyze, he can make changes. He has a 5-minute feedback loop where I have a 10-hour feedback loop. And I feel that the hard part here is that it's kind of like the reason I click on this is because I've seen the problem, right? I can relate to this. And I almost feel that this kind of tool, you might as well just say, I'm going to talk to the people that get it, because the other guys, it's like, they are you need to talk to the early adopters, because the other, it's not mature enough. And that's not their fault. It's just that they focus on different paradigms, or they're thinking of it from a different way, almost like they haven't experienced the problem in a certain way to then appreciate the value of what you're showing them, right? And then because we know that in a year from now, in 6 months from now, or in a month from now, you're going to have a better view. What I've found is that what you want to do is keep coming back with better and better and better representations until one day it clicks. And then they'll become super excited because they'll smile, right? Because then they'll get it. But I feel that at this level, there's a whole market that already wants to use this and is super frustrated because he doesn't have that ability to codify it. I think we just need to find those use cases that allows it, like how do I push this to my, or show this to my team? Because I don't like to push stuff to them. I like to show them paths So I need to show a path to my team so that they start to use the Glamorous Toolkit. So I mean, so and they'll get a lot of this, and some of them will get the users of it. So it's almost like we want to get people using it, even when sometimes they don't understand that's behind the scenes. The good news with tools like this is that there's a level down, a level down, a level down that gets very excited because you can keep going deeper and deeper and deeper into, in a way, the rabbit hole, where with most other tools you get stuck. And if you want to make change anything even minor, you can't, right?
Yeah, exactly. Wow, that's so cool to hear it. Very cool. Yeah.
So that's actually, for the other guys, here. So I think, Raphael or Stefan, right? Can I bring you into the conversation? Because I know you start using this as a way to analyze code, right? I think Raphael is saying it was Rust code, and Stefan was another technology. So yeah, I know you can't go into specifics, but I'm kind of thinking it'd just be nice to say, where was the area that you used it and added value? That almost, what was the alternative? Do it by hand or other tools that maybe weren't as effective?
Well, the problem that we were running into there was that we had some specifications that were 15 years, 10 years old, and they just didn't match the code. Mm-hmm. And we needed to make some changes there. Yeah. So I started using this because of the storytelling, as a way to describe the requirements and make a nice story of what this thing was actually supposed to do. Because there were lots of things that were no longer needed. There were lots of things that were somewhere in the code that were needed, but couldn't find out where they were described. And yeah, there were some people who worked in that company for a long time, 20, 30 years. And if you ask them the right question, they can answer. They can tell you everything about it. And they know that you need to talk to someone else to find out why things happen. But there is no systematic way of getting that done unless you just put it in a system. And if you put it on paper, then nobody reads it. If you put it in executable specifications, then I can make an example and say, well, what needs to happen in this case? I don't understand what happens if this is missing. If I get this twice, what then happens? Well, and then you have that conversation with experts, and they will tell you what happens.
So can you expand on the storytelling? Because I think what attracted me, for example, to Jupyter Notebooks when I saw it was not only a good way to do REPL, because I felt Jupyter Notebooks was a much nicer REPL, not as nice as the Glamorous Toolkit, but it was a nice REPL, right? But what I also liked was the storytelling. I found myself that I can now tell a story with code, with real data, with real information. So did you use it like that? So did you create one of these decks or one of these presentations where you can say, look, here's my analysis, and then actually use the Glamorous Toolkit's capability to actually be feeding the data almost from reality?
Yes. At that point, I did not use the slides yet. They are really nice, and I used them later, but not in that project. But what I did was use the thing with this pillar with document model, and I just took the documents they had and took the parts of it that I found interesting and made that into examples and made that into running code and tests, and just developed a domain model for it. Yeah. So, yeah, and then that was readable, and I could just export it to Confluence, the tool that I used. Yeah. So
I can actually show. I can show an example of what I think Stefan is mentioning. I don't know that project, but I can show a similar one.
Just one little thing, what you're saying there, Stefan. Where did you store the raw data? Was it on your models? Was it on GitHub? Was it on a Git repo?
Yes, that was a Git repo. Yeah, yeah.
So you had your raw data in a Git repo that was then consumed by the Glamorous Toolkit that then allowed you to create those presentations.
Yeah.
Or that
Yeah. There was multiple repos because there was a Git repo for the old source code where I used part from, and which I analyzed in the code that I wrote for the executable specifications. Yeah.
Cool.
Yeah.
So here, for example, is a case of imagine. So this is there's an actual system running here, which is a restaurant automation system. So imagine something like cozy corner here with a room and a kitchen, 2 tables in the room, and there's a waiter and there's a cook over here. And so the key element here of this system was how do these two communicate with one another without them knowing of each other. So that was the essence. And I'm not going to go into that details here, but basically here, John Waiter goes to table 1, takes an order, and then digitalizes it. And that order needs to find its way all the way to the cook. Now, of course, it goes to the cozy corner, and then here it gets transformed into another message that finds its way to the cook. And at this point, now the cook has to cook the food, right? And then at some point they say, okay, now the food is ready. Somebody should come and deliver it. And that message now goes away all the way to the waiter. Now, this is a picture that we drew on a whiteboard with business people, right? And it was like a wish. This is what we wish the system to be. But then we said, okay, now let's implement that. So here's a model. And if you can squint at it, you can say, for example, here you say, I want a venue called Cozy Corner here. I have an area called Kitchen in the Cozy Corner. I have a room in the Cozy Corner. I have table 1, table 2 in the room. I have waiter at table 1 and table 2, and I have Jeff cook at the kitchen, right? So this is what people are talking about when they say ubiquitous language, right? This is something you can read. And if you squint at it, you kind of imagine the picture that I drew before, right? But if I execute this, I have to imagine it. And that's the interesting thing. And so, right, so one of the things that we saw here, right, is that this is a static part, but then we have these messages, this dynamic part, and you see here the red thing gets transformed into a blue thing. So that's some sort of computation. So let's endow these actors over here with computation. So now they have abilities over here, and I can go inside there. I can actually, this is like a full editor over here. By the way, I have an editor inside the complicated visualization, right? So, but the more interesting thing, so up to now I visualized Cozy Corner, that's the static thing, right? And now I want to visualize the thing with the lines. But what's the thing with the line? Well, that's the actual dynamic entity. So it's the actual order. So now I'm inspecting the order, and now the order knows how to draw itself. And that's what becomes really interesting, right? Because now I see here that it goes all the way to the cook, right? And now the cook has an item on the to-do, and at some point the cook will say, okay, I'm done. And when it says I'm done, what happens? Well, it goes back to the waiter. So that's pretty cool, right? Because I just reproduced what we drew on a whiteboard. I reproduced it here. Now, here's the interesting thing. And then, of course, we can go and play with other things. For example, let's imagine we add a guest now at the table here, right? And the guest now orders a something directly, but just opens the phone and connects to the restaurant and orders something. So now the cook has an item on the to-do, and then it says, and it's, somebody should come and deliver it. What's going to happen? Let's go and see. Oh, look, it goes back to the waiter. Why? Because in this restaurant, that's how the design is. Like anybody can order, but the waiter serves. That's what it is. Well, what's cool about this is that now I just built kind of like a debugger, right? It's a domain-specific debugger, but it's an inspector. Now, how did I do this? Well, because I reified the messages. So now, like this goes into event storming, like having first-class events as a thing becomes important. And I got to, like, we first implemented the algorithm, but we couldn't visualize it. Why? Because we didn't have first class messages. But then we said, we want to draw this picture because it was meaningful when we communicate with the business people. And this pushed us to have first class entities. We changed the test we made, the functional test remained exactly the same, but the design changed just so that we can draw the picture. Now, here's where it gets more interesting. If I click on this Cozy Corner now, and I'm now visualizing the static side, of course, right? But now, of course, this one knows the log of the things that happen. This could be like coming from the database, for example, right? Mm-hmm. These are the messages that went through it. And if I now click on it, what do I see? I have a visual browser that a second level support team can use to reason about what's going on in the system.
Yeah.
This is how cool this whole feedback loop is, right? So that story that was there at the beginning now becomes a superpower, right? That you multiply your abilities. And so once you can do those, you can start building documents like this. So this is the document that Stefan was talking about, right? So these are now live documents that are actually doing those things. Right, so here I have my Jeff Cook. I can go and interact with it inside, inside there. And but then I can apply this one at all sorts of different levels of abstractions too here. So for example, if I always like to show this prices model here. So here in this case, you see some code and some execution over there. So let's just pick some complicated case over here at the end where you see a case where we take a concrete price of 100 euros, we discount it by 10 euros, we discount it then by 10%, and then we get 81 euros. And that's the printout. And again, like we're talking with business people, they are drawing these representations, and we're just making this is something that looks like a test, right? And if I can look at how this test is being built, it's being built like this. So that's the technical description. And this is something that the business people can look at. And so all of a sudden, my development environment becomes a rich place where very deep conversations can happen. And these are things that the user will never see. And we actually sometimes we turn these ones into even with, we talk with investors. So we work with startups so that they can build executable models of what they want, of their idea of the startup, to pitch to investors through executable pitches, so slides that are executable. Way before there is any system, for example. And so, yeah, that's one of those ideas. This goes on the line of what you were saying, Stefan?
Yes, that's exactly what we have been doing. Not so fancy, but yeah.
Right.
But that visualization is insanely powerful. Just I think I saw a bit there, just to clarify a little bit. So where is this? Can you go back to that intermediate representation? So that is stored in text-based format, right? And
you mean this one? Yeah.
No, well, yeah.
This is a mark.
Yeah, behind the scenes is a markdown thing, right?
Yeah. And okay, this is also Git, right? Fancy. This is stored. All sources are stored in Git. In fact, this here, what you're seeing here, this is actually a class comment of this specific class. This is how we draw our class comments. I don't know how you draw yours, but this is how I draw, this is how class comments could look like. Just normal. And so those are just stored as text, and then you draw them like this in your
All right, here's a question. Is there a way to represent, to render this on a web page?
Yes, that's what we did. That's what I did with exporting it to Confluence.
Yeah, but what did you export? You just the screenshots of it? Like, what does the export look like? Just the screenshot of the image?
No, well, it was one page with the text and the images were generated too.
Okay.
And yeah, you need to update it from the Git side, of course. Yeah.
But this part here has a certain type of degree of functionality, right? I'm assuming that gets lost then, right?
It does. That liveliness at this moment in time, that is not, you will not get it if you export it to the web. But there's just there's nothing conceptual. There's no conceptual limitation there.
Yeah, is this? But you said, what's the UI here? This is not JavaScript, right? This is that farmer.
This is Glamorous Toolkit.
Sorry, Glamorous Toolkit.
Yeah. It comes with its own graphical things. That, for example, just doing this thing, just having a full editor here with syntax highlighting and completion inside the drawing.
Yeah.
You're going to be hard pressed to do that in current graphical stacks. We actually implemented a whole graphical stack just so that we actually able to do anything like that.
Yep. Cool. All right, man. Look, I think, I just realized actually my screen was on the wrong thing. Oh, here we go. I can go this way. I think this was really, really good, man. I think I got a much better picture. So we definitely want to do a couple more sessions in April, right?
Let's do that.
We'll pick some topics, right? But this has been a really good roller coaster this week to try to, I hope I did it justice, right? I hope I managed to get the good concepts of how everything works.
Like, as I said, like your summary was just amazing.
Thanks. No, I see lots of potentials here, right? I think it's good stuff. And I think also at the summit, what I think is there's the summit is kind of on this intersection of lots of different tools. And, like the traditional summit is actually everybody on site. So it would be really amazing if so basically it would be like a case, because it's the whole day. And we have so it's usually on the place in London called Centre Park, no, outside London called Centre Park. So we have the villas. So it'll be a case where even if the original session would not have a lot of people, then we would be able to bring others and we're able to present it. And we always get, a lot more people interested, right? And it's a great intersection of the different types of, skills and techniques and tools and stuff like that. So we're trying to replicate that a little bit virtually now. But I do think there's lots of intersections that we can do here, lots of collaborations we can do, especially on things like threat modeling, architecture, security reviews, visualizations, DevSecOps, right? I think there's lots and lots of great opportunity here. So really cool, man. Look, thanks for your time. And Stefan, thanks for chipping in. I think that was really cool comments, and especially the storytelling. I feel that's a good element for this, which is already, it's a very, very powerful. Like you said, I can storytell at the level, almost at different levels, and you almost go down as much as that audience wants to see at that moment in time, right? So it's really useful. So thanks for your time.
Cool. Thank you very much.